Hi guys, welcome to this lesson, Quant revision for the SNAP exam 2020. Today we're going to deal with, we'll continue with ratio and proportion. Hi everybody, welcome to lesson 3 in Quant revision. I hope you guys enjoyed the previous two sessions on percentages and ratios. आज थोड़ा सा आगे बढ़ाएंगे. We'll deal with this topic of weighted averages and mixtures. My name is Anand Venkatesan. I'm an educator with Unacademy. I have done my engineering from VIT Vellore and then went on to do my postgrad from IIM Bangalore. As you can see, I have worked for about 4 years in the FMCG sales and marketing vertical, but I've more importantly trained students for almost a decade for the quant and verbal sections of aptitude exams. I'm now part of this exciting group of educators. Unacademy and we're trying to give away plenty of lectures on YouTube so that you guys can learn for free. Alright, here's the agenda. Here's what we will cover in today's session. As you can see, weighted averages. We'll understand the concept of weighted averages, then we'll know how to use the rule of alligation in these problems. Apply alligation both in weighted average problems but also in mixtures and solutions, problems on mixtures, and finally we'll deal with this tough problem type called removal and replacement. As you can see, there are many ways of you joining us on social media or on Telegram, so do subscribe. These are some weekday batches that are starting. They started very recently, 28th of December, the complete weekday batch and the absolute batch, both of which started yesterday. There is also the iconic batch that is kicking off, that kicked off yesterday. But I think what I want to also tell you is the Ask a Doubt feature, which is a beautiful, very exciting feature that Unacademy has recently gone live with. Whereby what you can do is you can take a photo of the doubt or the question that you have and post it on the Unacademy app, and if all is well, then our educators will reply back in double quick time and give you the solution to those problems, right? So do check it out. It's it's gone live. All you need is a valid subscription plan. As you can see, there are many available options for you. These subscription plans go from as short as a 1 month duration, but for as long as 6 months, so to 12 months to a couple of years, in fact. So do check out, and don't forget to use my referral code AV01 because that gives you a 10% discount straight away. Right, so here's the agenda. Let's start with today's session. Just give me a second. Alright, so what do we have today? We are learning about the weighted average. What is the weighted average? Well, unlike the simple average, the weighted average assigns different weights to observations, right? Like for example, अगर मुझे पता है कि in English, let's say I scored 50% marks, and in math I scored 80% marks, right? It sounds unlikely. ज़्यादातर लोग उल्टा स्कोर करते हैं. But if these are my scores, what is my overall percentage, right? Will that be A plus B by 2? Will that be 50 plus 80 by 2? No, it depends on English कितने मार्क का पेपर था, math कितने मार्क्स का पेपर था, right? It depends on the maximum marks. It depends on the quantum of the test, the weightage assigned, right? So for example, if English was for 100 marks and maths was also for 100 marks, then your overall percentage could have been 65%. That would be the simple average. But अगर English 100 marks का होता और maths 50 marks का होता, तो देखो क्या होता? Your score in English would be half of 50% of 100 is 50, but 80% of 50 is actually 40. So what you got is 90 out of 150 marks, right? And so if I knock off the zeros, then so I'll get 60%, right? Overall 60%. And why did that happen, right? Why did that happen? It happened so because the mark जिसका weightage ज़्यादा था, right? जिस subject के ज़्यादा marks थे, weightage ज़्यादा था, my score in that subject was low, right? Which is why my average score ends up being below the simple average, right? So that's something that happens when you assign weights. Your weightage will determine where the resultant value or the average value will settle down at, right? This is the formula. You take every observation A1, A2, A3, etc. and multiply every observation with the weight. I'm sure most of you know that your selection criteria in most B schools will consider your 10th marks, your 12th marks, your CAT score, your SNAP score, etc., but will also assign 10% weightage to 10th, 12%, 10% weightage to 12th, and so on. So what you do is you multiply your score with the weightage and then combine all of this together into a composite score, but you'll also divide it by the sum of weights. Since this is in percentage terms, if you add all the percentages up, you'll get 100%, which is 1, right? So that's the way that even B schools calculate your composite score. Well, when you're dealing with problems though, I think one challenge is to understand exactly what is getting averaged out and exactly what are the weights assigned in the weighted average problem, right? So I think what I'm going to do is I'm going to tell you the 4 typical scenarios that you're likely to come across, and also tell you what the weights and the variables themselves are going to be. So if you want to calculate the average cost price, this happens when you're buying from not just one source but from multiple sources, right? Supposing I want to buy rice, I buy from shop A, shop B, shop C, right? So what is my average cost price? Well, you'll take the cost price and average it out, but what will you use at the weight? The quantity that you purchased, right? Whether it's in liters or kilograms or any other unit, the quantity purchased will be the weights assigned. Similarly, if you're trying to calculate the average weight of different groups of people, maybe a classrooms, maybe different colleges, then the number of people in those groups will be the weights assigned. If you are trying to compare the profit percentage, you're accumulating profit percentages across different sources, maybe different companies or funds, then the overall average percentage of profit will be weighted by the investment into each of those avenues, right? Let's say you bought stocks for company A, company B, company C, right? And your return was a 5% profit on one, 10% loss on the other, 15% profit on the third, right? Then you'll take these percentages, but you'll multiply them with 5% of what? 5% of my investment there, or 5% of my cost price there, right? And so those would be the weights assigned to these variables. And lastly, average speed is also very, very commonly occurring in exams. So when you're trying to determine the average speed in the journey, which is which has multiple, let's say, segments, then in each segment you will consider the speed, but you'll weight that speed by the time period of travel, whether it's expressed in hours or seconds or minutes, doesn't matter, but the time of travel would be the weight assigned to speed, right? I think a reminder you want to you set for yourself is that since in the formula the average and the weightage, the weight assigned gets multiplied, right? So ask yourself, whichever thing I'm trying to average can possibly be multiplied with which variable, right? What do I multiply cost with? What do I multiply speed with? Obviously time, not the distance. What do I multiply percentage profit with? The base, cost price. What do I multiply, age or average weight of a class with? The number of people in the class, right? And so on and so forth. So it's fairly obvious, but then again, I'm going to leave it on the screen just so you guys can quickly recap this, right? The second most important thing to recap is the rule of alligation, because what it does is, in a weighted average problem, it helps me solve questions faster. But when do I use the rule of alligation? Well, usually you use the rule of alligation when the quantities that you're averaging and the average value, all of it is known. That's when you use the rule of alligation, right? Initial values as well as the resultant average must be known, right? That's the scenario where you'll use the rule of alligation. Well, how do I use the rule of alligation? Typically, you must have two things getting averaged out. So A1 and A2 are getting averaged out to give me the resultant as AW. What I should do is that I write these three things down in the shape of a triangle, right? Look at this diagram, A1 and A2 followed by the resultant average just beneath it, but in a triangular shape, right? And you'll also notice that I'm making these two arrows, one pointing towards the resultant and one pointing away from the resultant average. There is no convention on this, right? You can write it in any particular You can point them in any particular direction, but one has to be towards it and one has to be away from the result. Step number 2, what you do is you subtract. For each arrow you calculate a difference, right? Now while I've written it in specific terms, I've said subtract AW from A1 and A2 from AW. There's no hard and fast rule on that. But I think what you need to keep in mind is that for every arrow you will subtract, but the sense in which you subtract for the arrow should be the same for both arrows, right? For example, if the left arrow that points towards the average, if you are doing back minus front, if you are doing A1 minus AW, then you should repeat the same order for the second arrow also, and so you would do AW minus A2, right? So make sure that you keep the same sense for both arrows, and once you've subtracted the ends, the front and the back of the arrow, you write the difference at the opposite end, right? You don't write for the left arrow, you write the difference on the right. For the right arrow, you would write the difference on the left, right? So A1 minus AW, back minus front on the right, and for the second arrow, back minus front is AW minus A2, which you would then write on the left, right? And in the last step, you'd consider the ratio of these, differences that you've written and equate that ratio to the ratio of weights, right? Because what the rule of alligation says is that the weights will determine the, the distance of the resultant average from the individual initial values, right? So the ratio of these distances will be the ratio of weights themselves, right? And that's how you can use the rule of alligation, right? Quick recap of that. Next up is the rule of, is to deal with mixtures and solutions. Well, I think the first and foremost thing is to be able to convert percentages and ratios into values and back and forth, right? Let's understand this quickly by way of an example. I have an 80-liter solution with milk and water in the ratio 2:3. Parts of a whole will help me calculate milk and water. How much is milk? So milk 2 parts out of total 5 parts. So 2/5 of 80 and 3/5 of 80 would be milk and water respectively, right? If I want the concentration, I could still use parts of a whole. I could still do 2 out of 5 is milk. But for concentration, since I'm converting into a percentage, I'll multiply it with 100%, right? So milk concentration is, 2/5 of 100%. Water concentration would be 3/5 of 100%. If instead of ratio the problem gives me the concentration, well, I should still be able to use it. What is concentration? Percentage of the total volume, right? So if milk concentration is 20%, right, then I can calculate the volume of milk and water, right? Milk then would be 20% of 60, right? And obviously I can then calculate this. 0.2 into 60 is 12, and water would then be 80% of 60. That's 0.8 into 60 or 48 liters, right? So it's fairly easy to, if you're given concentration or ratio in a problem, fairly easy to sort of calculate volumes. And obviously if I give you concentration and ask you for the ratio, could you do that, right? 20% milk means 80% water, right? So milk to water would then be 20% is to 80%, that's 1:4. Right? So back and forth is something that you'll have to do with mixture problems, so make sure that you're good at it. But the typical mixture problem will usually, involve combining two mixtures, mixture 1 and mixture 2, both containing the same elements. You combine them to create a resultant mixture 3, right? And so the typical approach you'll use is that you would break down the constituents in mixture 1 and mixture 2, right? By using whatever is given in the problem, whether it's ratio or percentage. You'll break mixture 1 down into milk and water, mixture 2 down into milk and water. Then you would add these two, right? You'll combine, since mixture 1 and mixture 2 are added, milk in these two will get added, water in these two will get added to result in the milk and water in mixture 3. And finally, the problem will describe mixture 3. So apply the given constraints, whether it's ratio or concentration or something else. About the mixture 3 is, that constraint, that condition is applied to values that you just calculated, and once you form equations, you can solve them to determine the unknown values. So that's the manner in which we solve a mixture problem. Obviously, that's not the only way. You can also use alligation. You could also say, remember that you will apply alligation to the concentration of mixtures, right? So let's say I'm mixing mixture 1 and mixture 2. Then the milk concentration in mixture 1 and milk concentration in mixture 2, A% and B%, will be alligated with the resultant concentration in mixture 3, right? So A%, B% and C% in mixture 1, mixture 2 and the resultant mixture. And once you alligate this, right, C minus A minus C and C minus B respectively, the ratio would be the ratio of volumes, right? So remember, you can apply alligation, but it would apply, you would apply that to the concentration to get the ratio of, and don't make a mistake of this, on this, the ratio of total volumes. V1 and V2 are total volumes, not volume of milk and volume or volume of water. They will always be the total solution volume. So resultant will always be the volume of the solution, not the ratio of that solution volume, right? All right. Well, the last problem type, which is a slight sort of variation of the mixture problem, is when you remove and then replace, right? So what happens here is that a fraction or a portion of the mixture is removed, and whatever you are removing is then replaced. Uski jagah kuch aur add back karte hain, whether it's pure substance or maybe you add another mixture. Either ways, you remove and then you replace, right? The meaning of the process is quite clear. You remove and then you replace. And when that is happening, the approach is usually to focus not on the quantity removed, is to focus on the fraction removed, है ना? For example, अगर मैं एक glass milk पी रहा हूँ and if I drink, then if you tell me I drank 100 ml, you probably won't know. But if I tell you I drank 1/3 of the glass, it's immediately apparent. So similarly, removal and replacement problem में we'll usually focus on what is the fraction that gets removed and what is the fraction that is remaining, right? So if out of 100 liters or out of 50 liters, if I let's say remove 10 liters, then I'm removing 1/5. And if I remove 1/5, what will be left will be 40 liters out of 50. So what is remaining is 4/5, right? So when a fraction of the solution is removed, then the same removal fraction will apply to all constituents. मतलब अगर आप एक solution है जिसमें milk और water है, so when you are removing it, then if you are removing 1/5, then milk will also reduce by 1/5 and water will also reduce by 1/5. It's not like those proportions are going to change. And this is a fact that we'll use in the problem, right? How do we use this problem, right? Remember, you're removing, but then you're replacing with usually a pure substance. So जिस substance को आप replace कर रहे हो उसका volume तो increase करेगा, because if I remove 10 liters from a solution, it will contain both milk and water. But when I add back, if I add back water, then essentially what you're doing is you're replacing milk with water, which means milk will decrease, water will increase. And the moment you make that kind of an inference, you'll say, let's work with the quantity that reduces. And there is a direct formula for that, right? The direct formula is the quantity, the substance that reduces, its final volume will be initial volume into something called the fraction remaining whole raised to the power n, where n is the number of iterations, right? So this is a formula that you can directly use. Obviously, points to remember, applied only on the substance that is reduced in volume, जिसको replace नहीं किया जा रहा है, जिसका volume घट रहा है, उसी पे apply कीजिए ये formula. Number 2, the fraction remaining depends on the fraction removed, right? If you are removing 1/4, then the fraction remaining would be 1 minus that, so 3/4. And finally, if you are getting the volume of the substance that is reducing, then the volume of the other substance would be total solution volume minus the volume of the first substance, right? So you can apply the formula only on one substance, but you can use it to derive the volume of other substances too. All of this is based on the assumption that the volume remains a constant value, right? It does not waver it. You add and remove, but you essentially maintain it in the solution. Okay, so those were the basics of mixtures problems, right? Averages and mixture. There are 4 types of problem types. In this chapter, we'll quickly run through a few questions from each of them. ये पहला question basic है. Average weight of 19 men. You can see that this is a group of people, right? So group 1 has an average of 74 kgs and group 2 has an average of 63 kgs, and you want the average of all of both groups put together, G1 and G2 put together, right? So simply multiply, use the formula, right? A1 into W1 plus A2 into W2 divided by W1 plus W2, right? And sometimes when you're applying this formula, don't be bullheaded, don't be, blind spotted, because you should look at what are the weights. 19 men, 38 women, right? Is there a simpler way of representing them in ratio terms? Yes, think about it. 19 and 38. What is their ratio? 19 ones are 19, 19 twos are 38. So instead of considering the absolute weights, you could also consider their ratio. So 1 and 2 means that the denominator would be 1 plus 2, that's 3. So my answer would be 74 plus 126 divided by 3. That's clearly going to be 200 by 3. So my answer would be closest to 67 kgs. So a couple of tricks that you need to keep in mind, right? You can use the weighted average formula, but a smarter thing is to not use the weights but their ratio instead. Okay, here's another one. 12 kgs of wheat flour costing 16 and then 4 kg of corn flour costing 2 rupees. They are mixed, so you're buying 12 kgs of wheat flour and 4 kgs of corn flour, which means you're combining them to make 16 kgs of the mixture, right? And this mixture then you're selling at a price of 16 rupees per kg. So you're given the selling price, right? So to calculate the profit, you also need the cost price, right? So what is the average cost price? Average cost price will be a weighted average, right? So price 1 into quantity 1 plus price 2 into quantity 2 divided by sum of quantities 12 plus 4. Obviously I could have also done 1 and 3 instead of the actual quantities. 48 plus 2 is 50. 50 upon 4 is 12 and a half. So my cost is 12 and a half rupees per kilo, but my selling price is 16 rupees per kilo. So the percentage of profit would be, I make 3.5 rupees per kg, right, divided by 12.5 rupees per kg being my cost. Remember, I'm not considering the quantity because you're selling, even if you sell 40 kgs of the mixture, right, you would have to make them in the same proportion, right? So the profit that you'd make on selling 1 kg would be the same percentage profit you would make. Oh, okay, this is the value of profit, not the percentage profit. So you're making 3.5 rupees per kilo, right? And so for 40 kilos, I'll multiply this with 40. That's 35 into 4, 140 rupees of total profit I would make in this transaction, right? Okay. Let's now look at some problems where we'll use alligation, right? Remember, alligation तभी use करेंगे जब A1, A2 और resultant पता हो, right? Okay, look at this. Companies A and B, I invested through 20,000 and 30,000 in these companies and they gave returns of, percentage profit. Return is percentage profit. तो यही average out हो रहा होगा. 15% and 20%, are what the returns they gave. But I want the overall return, right? So मुझे तो resultant average चाहिए, तो average के लिए तो alligation नहीं use करेंगे, into इनका ratio ले लेते हैं instead of weights themselves 2 and 3. So 15% into 2 plus 20% into 3 divided by 2 plus 3 5. कितना आ रहा है? 30 plus 60 is 90. 90 by 5 is 18%. So what was the overall return on capital? Well, of the money I invested, I make back 18% overall. वेटेड एवरेज है. यहाँ एलिगेशन नहीं लगाएंगे, राइट? रिमेंबर, एलिगेशन तभी लगाने का फायदा है जब रिजल्टेंट पता हो. ओके, कैन आई यूज दैट हियर? व्हाट आर वी डूइंग हियर? यू आर मिक्सिंग सब्सटेंसेस, यू आर मिक्सिंग शुगर, one variety of sugar with another variety of sugar, right? And the resultant mixture's cost price is given to you, right? So cost price of the first mixture is 40, first variety is 40, second variety is 80, and the resultant between 40 and 80 is actually 65. So let's use alligation. Point one arrow towards, one against. Then for every arrow we'll subtract, right? I'm doing front minus back for the left arrow. I'll write that difference on the right. For the right arrow, I'll write the difference on the left, but in the same sense, front minus back. So 80 minus 65 on this side, right? And what is it I get, 80 minus 65 is 15, 65 minus 40 is 25. So this should be the ratio of weights, right? Now when you're mixing substances, then your weights will be the quantities that you're used, right? Weights will be the quantity used. So I should mix them in the ratio 5 3s are 15, 5 5s are 25. So if I want to make 8 kgs of a mixture, if I want to buy 8 kgs, then 3 kgs and 5 kgs respectively, were purchased. Okay, but I am told that I buy 45 kgs from the first shop. So then I can, basically I'm given that W1 is 45. So let's use that. 3 by 5 is equal to 45 by W2. means 3 into 15 is 45. So W2 will be 15 into 5, that's 75 kgs, right? So gives me an answer very, very quickly. Don't need to use the A1 W1 plus A2 W2, formula. You can actually do this very, very quickly. Right? I hope alligation is clear. I hope the illustration helps you understand how to apply alligation. Let's look at one more problem, right? Remember, most problems in alligation will look like this. You're mixing two varieties to create a mixture, right? But then sometimes you'll get variations. Like this one is a variation. You have two kinds of employees in a company that you work for, right? There are managers and there are executives, right? Managers earn 80,000, executives earn 30,000 only, and the average salary of an employee in the firm is only 50,000, right? So which means I am weighting their average salaries with the number of people. Weights are going to be the number of people at each of these categories, right? Managers and executives. But we'll get to that later. Let's apply alligation. Back minus front 30 and back minus front on this side 20. This gives me the ratio 2:3. So number of managers M divided by number of executives E should be in the ratio 2/3. Do I know any of these? Well, how many? There are a total of 200 employees in the firm, right? So let's say this is 2x and 3x respectively. So then we are given 5x as 200, which means x will be 40, which means the number of executives E would be 3 times 40, that's 120, right? So that's my answer. Number of executives employed by this firm would be 120 in number, right? Again, a very, very simple application of alligation. है ना? ये actual question है, I think snap का ही. Rasmukh Bhai sells Rasgulla at 15 rupees a kilo, right? Well, I'm not a big fan of Rasgulla. I personally prefer the gulab jamun, but because this one is too sweet, man, as a delicacy. Anyhow, so this shopkeeper sells Rasgulla at 15 rupees per kg, and the Rasgulla is made up of flour and sugar in the ratio 5:3, and the prices are also in the ratio 7:3. So we can assume the prices to be 7x and 3x. Remember, I can't assume a value because I'm already given a value, rupee value, right? But I can assume the quantities. Let's say I assume 5 kgs and 3 kgs are mixed, right? So how much do I spend, right? So my cost price would be 7x into 5 plus 3x into 3, and since I'm doing an average, you will divide this upon the total quantity, which is 8. So what does that get me? 7 into 5, 35. 35 plus 9 is 44x upon 5. This is my cost price. Oops, I think this part is missing. Does he earns how much profit, right? That's not, I think the typo is not given. Let's say we'll assume a value. Let's say he earns 20% profit, right? So then 20% profit means that his selling price would be 120% of cost, right? 20% ज़्यादा का बेचेगा, 120% में बेचेगा. Selling price दिया हुआ है मुझे, हाँ बिल्कुल दिया हुआ है 15 rupees a kilo. That should be 120%. So 120 upon 100 into what? The cost price. That's 44x upon 5. If I solve this, I'll get the value of x, right? And I'm not showing you the calculation because 20% मैंने assume किया था ना, दिया नहीं हुआ था, तो I don't know if it's the right one. So assuming, given the value of profit percentage, you can calculate x. Once you calculate x, you will get the cost price of sugar, right? So you can determine the answer to this question. Okay, another one where in fact explicitly alligation is going to come into play. I mix a variety of oil costing 100 with another variety that costs 150. So your 100 rupees per liter with 150 rupees a liter was then sold at 144, but 20% profit means that you sell it at 120% of cost, right? Which means 144 will be 120 upon 100 into CP. So I'll get the CP as कितना आ रहा है, ये 0 0 कट जाएगा, 12 into 12 144 आएगा, CP आ जाएगा 120. तो resultant cost price मैं यहाँ alligation में use कर लेता हूँ in the middle. So two varieties result in 120 as my cost. Front minus back 20, front minus back 30. Mix them in the ratio 3:2, right? Which means 3 upon 2 will be ratio of quantities bought, quantities used for each of these varieties. I know 30 liters were used for the first variety, so 3 by 2 should be 30 upon x, so x will be 20 liters, right? So how much of the second variety is needed? Well, I need 20 liters of the second variety. Okay, right, another question on alligation. This one I'm going to leave on the screen for you guys to solve yourself. Instead I'm going to move on and try and apply alligation in mixtures, right? A 300 ml solution, right? Think about it. I compare this to mixture 1 plus mixture 2 results in mixture 3, right? What am I combining? I'm combining a lime solution. So this one is lime solution, which contains 20% lime by weight, right? And what are you adding to it? You're adding lime concentrate. Lime concentrate means pure lime, right? So to a lime solution you're adding pure lime, right? And what you want is that the resultant should become another lime solution. Obviously, if you're adding pure lime to it, its concentration will increase, and we're given that it must increase to 40% lime, right? So how much quantity are you added? How much lime concentrate should be added if you know that mixture 1, the original lime solution, had a volume of 300 ml, right? Now, if you want to apply alligation, then you should remember that alligation applies to concentration. So are we given concentration in the first solution? Yes. What about lime concentration in the second solution? Well, it's pure lime, which means it should be 100% lime. So concentration is 100% over here, and the resultant is 40% lime. So if you alligate these three values, front minus back 20, front minus back 60, this indicates to me that I should mix them in the ratio 3:1, which means 3 by 1 will be the volume of the first solution upon volume of the second solution. So 300 upon x, which means I'll get x as 100 ml, right? So how much lime concentrate should I add? I should add 100 ml of lime concentrate to 300 ml of the original solution, and that will get the job done. Okay, here's a variation, right? Milk and water. Now we're not given concentration, we're given ratio, right? 5:2 and 3:5 is the ratio of milk and water in the two vessels. So in what ratio should we take quantities and mix them so that the resultant has equal volume, right? Remember, what you're told is that in the basic mixture problem, that's M1 plus M2 gives me M3, right? What happens here is that you are given ratio of milk and water here, you are given the ratio of milk and water here, and you are also told the ratio of milk and water here, right? Now you could do one of two things. You could either convert this into concentration, or maybe convert it into a fraction which corresponds to concentration. Like for example, I could convert this into a fraction 5/7, right? So this is 5/7 milk, and in the second solution 3/8, remember, parts of a whole, 3/8 is milk, and in the resultant 1/2 or half is going to be milk, right? So basically you will translate the problem into, okay, I take a solution where milk was 5/7 of the solution, and then I add it to another solution where milk was 3/8 of the solution. In what ratio should I mix them so that the resultant is half milk, half water? So I can basically now alligate these values, 5/7, 3/8 and 1/2. You can alligate, right? So I could do 5/7 minus 1/2, the difference, back minus front for the arrow, that the left, and for the right arrow, back minus front will be half minus 3/8, right? That's 4/8 minus 3/8, and hence that is 1/8 is to, I'll get 3:14, right? Which means mix them in the ratio 1/8 into 14/3, that's 7/12, right? So this basically says that the two mixtures must be combined in the ratio 7:12. That's option A. Okay, and we're almost running out of time, so I'm gonna solve this one and let you guys try this question yourself, right? One containing mixtures and of spirit. Let's try this one. A cistern contains a certain quantity of milk and water, right? So I have a solution, mixture 1, and to this 30 liters of water is added, right? So you're adding water to it, 30 liters, and you're told that the second mixture that you create has 60% milk, right? Instead of 30 liters of water, if you added 50 liters of water, then the concentration, obviously if you're adding less water, the concentration will not decrease by as much, right? So if it's become 60% on adding 30, then on adding more water it should become less than 60. And the question says the milk concentration changes by 15 percentage point, which means it will become, oh by the way, this is M2 plus 50 liters, right? So on adding 30 liters of water to the, on further adding 50 liters, right? So if to M2 you are adding, you know, water and the concentration changes by 15 percentage points, then I know that it will become more dilute, so it will become 45% milk, right? So what I can now do, and we want the volume of water in the original solution, right? So I can use alligation, but in this problem I don't necessarily need to use, I mean I can start with alligation in the last step, right? I know I took a 60% solution and I converted it into a 45% solution by adding 50 liters of water. So 60% milk, water contains 0% milk, results in 45% milk. So if I alligate, I'll get the ratio as 45:15, which is 3:1, right? So this tells me if I add 50 liters of water, 3/1 will be X liters unknown, right, divided by water, which is 50 liters, which means X will be equal to 150 liters. So how much water are you, milk are you, milk solution are you taking? We had 150 liter solution of this, right? But if after adding 30 liters it become 150 liters, then clearly I must have started with 120 liter solution of milk and water. So how much water did the original solution contain? Well, in the resultant solution, 150 liters, how much is milk and how much is water? In this 150, 60% is milk. So milk should be 60% of 150, that's 90 liters. And so the remaining water will be 16 liters in the resultant. But this is the water after adding 30 liters, right? Which means before adding in the original solution, how much water must have been contained? M1 must have contained 30 liters of water and the remaining 90 liters must have remained milk. It's the only way that this arithmetic will work out. Okay, and finally we come to removal and replacement. थोड़ा सा कठिन सवाल है, but remember the formula. The formula is final is equal to initial into fraction remaining to the power of n, where fraction remaining is 1 minus quantity removed divided by quantity of the solution. Right, let's do this. I have a 100 liter solution which contains 80% milk. 25 liters are removed, so immediately do the fraction removed. So 25 out of 100 is removed, so 1/4 is removed. So immediately you will say F will be 1 minus 1/4, that's 3/4. Okay. This is then replaced with an equal volume of water, which means water will increase, which means milk will reduce. So this formula should be applied to milk. कैसे अप्लाई करें? मुझे फाइनल वॉल्यूम मिल्क का निकालना है अब इस फॉर्मूले से. तो इनिशियल मिल्क चाहिए मुझे. तो इनिशियली 100 लीटर में मिल्क कॉन्सेंट्रेशन क्या दिया हुआ है? 80% मिल्क, which means I is 80 liters. What else have we given? Right, we've already calculated F. Right, how many times is done? Is this operation done? This operation is done 3 times in total. So my final value should be 80 into 3/4 when cubed. So that's 80 into 2, 3 cube is 27, 4 cube is 64, 8 8s are 64, 8 10s are 80. My answer is 270 upon 8. 8 3s are 24, 38, 3s are 24, 7 5. Right, so 33.75 liters is the final volume of milk in the resultant final solution. Right, we'll try and do one more question before we bring this session to a close. A container, it has 40 liters of milk and you're removing 4 liters of milk from here, and which is replaced by an equal quantity of water. Right, so remember you're removing you are removing 4 out of 40. So the fraction removed would be 4 by 40. That's 1/10. Which means the fraction remaining F would be 1 minus 1 by 10. That's 9 by 10. Right? And since you are replacing with water, we'll work with milk. Right? So you're starting with 40 liters of milk. So initial value is 40. and hence the final value should be initial value into the fraction remaining 9 by 10 raised to the power of, I don't really know, right? In fact, I'm given 4. This is repeated 2 times after the first time, which means it's done 3 times in total. So that's 40 into 9 cube, 729 divided by 10 cube, that's 1000. Knock off 1 0 and multiply. So 2916 upon 100 is 29.16 liters. Yeah, that's option C. Okay, let's try a slightly different one, right? 8 liters are drawn from a cask full of wine, right? We don't know the volume of the cask. Let's say the volume of the cask is X liters. So you're removing 8 out of X. So quantity removed is 8 by X. So quantity remaining, fraction remaining, sorry, would be 1 minus 8 by X. And this operation is performed 3 more times, so 4 times in total. And what we are given is that and you are replacing it with water, so we'll know that the formula should be applied on wine, right? So we'll say final is equal to initial into quantity remaining, that's 1 minus 8 by X raised to the power of 4, right? I'll take stock of this. The ratio of wine left in the cask, so final wine, to the capacity of the cask, right? Capacity of the cask will be final plus initial, because together their volume will remain a constant. So F by F plus I is given to me as 81 by 256. Right? In fact here the cask volume is assumed to be X, so which means this can be written as 81 upon X, which means, sorry, 81 upon 256, right? And you already know that the total volume is (81 by 56), right? So I can say that final volume of wine would be initial volume. Okay, sorry, we are given final will be 81 by 256 upon 81 upon 256 into the total volume, which is X. Cask volume remains a constant, so that becomes X. So if I apply that in the formula, then I'll get 81x upon 256 equals X into 1 minus 8 by X to the power of 4. Right? So the X goes away. Then if you take a 4th root, you'll get 3 by 4. And if this is equal to 1 minus 8 by X, then 8 by X will be, right? 8 by X would be 1 minus 3 by 4, that's 1 by 4, which means X is 32 liters. So the capacity of the cask would indeed be 32 liters. That's the correct choice. Okay, on that note, I'm going to stop today's session. I hope this was fun. I hope this was comprehensive as well. Remember, we've touched upon 4 very important question types: the weighted average problem, the alligation rule of alligation, the basic mixture problem, as well as the removal and replacement problem. I want you guys to do a lot of practice on this topic because it's an important topic. It's also a tricky one, and you get better only by practicing, right? So make sure that you do that. Do check out the Unacademy app, because besides the sessions that we do here, I also go live with special classes. That's also free on the Unacademy app, and special classes are not conducted just by me, but by many other educators, right? But if you want to join a batch there, you will need to subscribe, and all you need to do is download the app, install it, press choose your goal and click get subscription, and that will show you these plans starting from a month all the way till 24 months. Ideally choose the longer term plan, but make sure that you use my referral code AV01, because that gets you a 10% discount, right? So make sure that you do that. And remember, Unacademy is also offers a lot of programs on different exams. So do spread the word. Do let your friends and other extended network know to follow our channel. we have an MBA channel which is diverse from other channels. But there are also Telegram channels where you will get notifications about the kind of content that comes up on our YouTube channel. Do click the like, share and subscribe button. That's my time. Thanks a lot, guys. Have a great day, and I will catch you very, very soon tomorrow. Same time, 6 o'clock. Join me for time, speed and distance. Bye-bye. Have a great day.